Hello students, let us continue the session on surface area and volume. In the last session, we discussed the questions from exercise 13.2. In today's session, we shall take up exercise 13.3. The first question here is, a metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. You must know that whenever one particular solid is recasted into another shape, their volume will remain same. So we need to equate the volume of both the solid shapes. First, let me list out the given things. They have mentioned the radius of sphere as 4.2 centimeter. I'll call this as R1, 4.2 centimeter. They have also given the radius of cylinder. I'll call this as R2, 6 centimeter. We need to find the height. So let the height of the cylinder be h. Here we will equate the volume of metallic sphere equal to volume of cylinder. Volume of the metallic sphere is 4 by 3 pi r1 cube, which is equal to pi r2 square h, which is volume of cylinder. So 4 by 3 into pi times of R1 is 4.2. So 4.2 whole cube equal to pi times R2 is 6 square into h. Here pi will get cancelled. We need to find the value of h. So h will be equal to 4 into 4.2 multiplied thrice divided by 3 multiplied to 6 into 6. On simplification, we get it as 2.74 centimeter. Therefore, the height of the cylinder is 2.74 centimeter. Second question. Metallic spheres of radius 6 centimeter, 8 centimeter and 10 centimeter respectively are melted to a single solid sphere. Find the radius of the resulting sphere. Here there are 3 spheres, smaller spheres. They are recasted into a single solid sphere. We need to find the radius of the resulting sphere. Let me consider the radius of first sphere. As R1, which is equal to 6 centimeter. Radius of second sphere R2, which is 8 centimeter. Radius of third sphere R3, which is 10 centimeter. Let the radius of the new sphere or the resulting sphere, I'll call it as R. As per the question, it's very clear that volume of three spheres together will be equal to volume of new sphere. Volume of a sphere is given by 4 by 3 pi r cube. Here if I take 4 by 3 pi as common, I'll be having r1 cube plus r2 cube plus r3 cube equal to volume of the new sphere is 4 by 3 pi times r cube. Observe it carefully. You have 4 by 3 pi, 4 by 3 pi in both left hand side and right hand side, hence they get cancelled. Let us substitute the value here. R1 cube is 6 cube. So 6 cube plus R2 cube is 8 cube plus 10 cube equal to R cube. This implies 6 cube is 216 plus 512 plus 1000 is R cube. So R cube will be 1728. I need to find the cube root. You have to follow prime factorization method to find the cube root. This is actually a perfect cube. We get it as 12 centimeter. So the radius of the resulting sphere is 12 centimeter. Question number 3. A 20-meter deep well with diameter 7 meter is dug and earth from the digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. Here, the well will be in the shape of a cylinder, and this cylinder has got 20 meter depth, which is height of the cylinder, 7 meter diameter, hence the radius is 3.5 meters. Let me consider the height of the platform as capital H. Let the height of platform capital letter H. Here you must know that volume of the earth dug out is equal to volume of the platform. Here, volume of the earth dug out is in the shape of a cylinder. I'll use pi r square h, which is equal to LBH, LB into capital H. They have given length and the breadth. We need to find height. Pi value, I'll take it as 22 upon 7 into radius is 7 by 2 into 7 by 2 into the height of the cylinder is 20, which is equal to 22 into 14 into capital letter H. So I need to find capital letter H. This will be equal to 22 into 7 into 7 divided by, into 20 divided by 2 into 2 into 22 into 14. Here 22 will get cancelled. There is one more 7 here. This 7 is in the denominator. This 7 also get cancelled. Now 4 5 times is 20. We'll be getting 35. 7 ones are 7 2 times 5 by 2, which is nothing but 2.5 meters. Therefore, the height of the platform is 2.5 meters. Similar question, question number 4. A well of diameter 3 meter is dug 14 meter deep. The earth taken out has been evenly spread to form the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So it would look like this. This will be the structure of well. The outer side, whatever you are seeing, is a ring. This particular thing is called as an embankment. Embankment. Some of you must have seen the wells will be having a structure outside for protection as well as for the support for taking water from the well. That particular support itself is called as an embankment. Here they have mentioned that the diameter of the well is 3 meters, so the radius of well will be 3 by 2 meters. The depth of the well is given. The depth of the well is nothing but the height of the well, which is 14 meters. They have also mentioned the width of embankment. This is 14 meter. Pardon, 4 meter. Width is 4 meter. So, if I speak about the internal radius, this will be 3 by 2 meters, and outer radius will be 3 by 2. We need to add 4 meter to that because the width is 4 meter. We'll be getting it as 11 by 2 meters. Now, according to the question, the earth dig out will be equal to volume of embankment. Earth dugout is in the shape of a cylinder, so pi r square h will be equal to pi times r1 square minus r2 square. I have to consider the internal radius as r1 and the outer radius as r2. R2 square into h. Larger one I'll take it as r1 and this I'll take it as r2. That would help us. Here the value of pi, they get cancelled. R square is nothing but 3 by 2 whole square into the height of the cylinder is 14. This is equal to r1 square, since I have taken the larger radius as r1, so 11 by 2 whole square minus 3 by 2 whole square into h. This h has to be found. Now we get h as 9 by 4 multiplied to 14. Then we need to simplify this. Here it's 121 by 4 minus 9 by 4. 121 minus 9 is 112. So I need to multiply this with the reciprocal 4 by 112. 4 will get cancelled. 14 multiplied to 8 will be 112. So h will be equal to 1.125 meters. This will be the height of the embankment. Question number 5. A container shaped like a right circular cylinder having diameter 12 centimeter and the height 15 centimeter is full of ice cream. Ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. As per the question, let me mention the given things. The radius of cylinder, I'll call it as R1. This will be half of this diameter 12 by 2, which is 6 centimeter. Height of the cylinder is 15 centimeter. Let me call this as H1, which is 15 centimeter. Height of the conical part let me call this as H2, which is 12 centimeter. Radius of the conical part will be R2. Let me take 6 by 2 because diameter is given as 6. So 6 by 2, which is 3 centimeter. This will be same as the radius of hemisphere. Let me consider the number of ice cream cones as n. So volume of cylinder will be equal to number of cones multiplied to volume of cone added to volume of hemisphere. What is volume of a cylinder? It is pi r1 square h1 multiplied to number of cones times volume of cone is 1 by 3 pi r square h. Here I need to consider r2 square h2 plus volume of hemisphere is 2 by 3 pi r2 cube. Substitute the values. What do we get? We get, here you observe pi being common, it can be taken as common thing, and left hand side pi and right hand side pi, they do get cancelled. We'll be getting r1 square into h. r1 square is 6 square multiplied to 15 equal to n times of. Now pi is not there, so 1 by 3 into r2 square, which is 3 square into the height is 12 plus 2 by 3 into r2 is nothing but 3 cube. So one of the 3 get cancels here, also one of the 3 get cancels, and we get n value as 36 into 15 divided by, what is the simplification of this? Here only one 3 left, 3 multiplied to 12 will be 36. Here one of the 3 get cancels, 2 square is 9, so 3 square is 9, 9 times 2 is 18, 18 added to 36 is 54. Simplify this, we get n value as 10. So the number of cones filled with ice cream is 10. Question number 6. How many silver coins 1.75 centimeter in diameter and thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 into 10 into 3.5 volume centimeters? They have mentioned the thickness and the diameter of the silver coin. The diameter is given as 1.75, so the radius of silver coin will be half of the diameter. Radius of coin is, I'll take it as small letter r, 1.75 upon 2. This will be 0.875 centimeters. They have given the thickness of the coin, it's same as the height. Height of coin is h1. I'll take this as 0.2 centimeter. Here they have given the dimension of the cuboid. Length is 5.5, breadth is 10, and the height is also given, it's 3.5. So n times, if you consider the number of coins as n times the volume of one coin will be equal to the volume of cuboid. You must know that this coin is same as a cylinder. The volume of a cylinder is given by pi r square h. Here it is pi r square h1. This will be equal to volume of cuboid, it's LBH. So I need to find the value of n. N will be equal to LBH upon pi multiplied to r square multiplied to h1. So length is 5.5, breadth is 10, and the height is 3.5 divided by r1 square is 0.875 multiplied twice 0.875 into h1. H1 is 0.2. Pi value I have to take, so I'll write 22. The denominator numerator becomes 7. This has to be simplified. Please try it out. You will get 400. Therefore, the number of coins is 400. Question number 7. A cylindrical bucket 32 centimeter high with a radius of base 18 centimeter is filled with sand. This bucket is emptied on ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius as well as slant height of the heap. The cylindrical bucket is having 32 centimeter as the height. Radius of the base is 18 centimeter. Alright, so radius is given as 18. It's not the diameter. The radius of the base is itself is 18. This bucket is emptied on the ground and a conical heap of sand is formed. It would look like this, and the height of this cone is 24 centimeter. Here, the radius of the cylindrical bucket is 18 centimeter. Height of the bucket is 32 centimeter. Let me call this radius as r, this as the height h, and they have given height of conical heap. Let me call this as capital letter H is equal to 24 centimeter. For instance, let me consider the radius of conical heap as R1. Then you must know that volume of sand in the bucket will be equal to volume of conical heap. Let's substitute the formula here. This is in the shape of a cylinder, so pi r square h will be equal to 1 by 3 pi r1 square capital letter H. Both the side there is pi. I'll first cancel that out. R square is 18 times 18 into the height is 32, which is equal to 1 by 3 times r1 square. What is r1 square? It is to be found. So r1 square into height is given as 24. 3 8 times is 24. This can be simplified. This will be 4 times. So we get it as 18 square into 2 square as the value of r1 square. So r1, we can find it out. It is 18 2 times 36. Now I need to find the slant height. Radius is found. Now the slant height will be root of 36 square plus 24 square. 36 square is 1296 and 24 square is 576. Add them up, we get 1872 root. Therefore, it is 12 root 13 centimeter. This is how you can find the slant height as well as the radius of the conical heap so formed. Next question. Water in a canal 6 meter wide, 1.5 meter deep is flowing at the speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed? They have mentioned the canal and it is having 6 meter as the width, 1.5 meter as the depth, and water is flowing at the speed of 10 kilometers per hour. Here very important thing is to find area of cross section. Here this is the cross section. This part is cross section. 1.5 meter into 6 meter would give area of this cross section. This area you need to multiply with the speed of the water to get the volume of the water. Okay, let's do that now. Let me mention what are the given things. Here the width of the canal is given. The width of canal is 6 meter. They are also given the depth of the canal. So depth of canal is 1.5 meter. They have mentioned the speed of water flowing is 10 kilometers per hour. Very important thing is the width and the depth is given in terms of meter. So I need to convert this kilometer per hour as in meter per minute. So 10 multiplied with 1000, because 1 kilometer is 1000 meter, divided by 1 hour is 60 minutes. So by 60 we'll get the unit as minute per meter per minute. So one of the zero get cancelled. Let me keep this value as it is. It's 1000 upon 6 meter per minute. Something may get cancelled. So we can find out the volume of the water flowing in a minute, in 1 minute, will be equal to area of cross section into speed. Here the area of cross section is 6 into 1.5 into speed. It is 1000 divided by 6. We get in terms of meter cube per minute. So 6 and 6 will get cancelled. 1.5 into 1000 is 1500. So 1500 meter cube will be the volume in a minute. So when it is calculated for a minute, I need not mention this. So 1500 meter cube. This is for a minute. Here they are mentioned for 30 minutes. So volume of water in 30 minutes will be equal to 30 times 1500 meter cube. This will be equal to 45,000 meter cube. Let the area of irrigated field be some a meter square. So volume of water from canal in 30 minutes will be equal to volume of water in the field. Therefore 4500 and 45,000 multiplied are equal to, you have to equate this area into breadth. Oh, 8 meter is the height, so area into height. Here, very importantly, they have given it as 8 centimeter. I need to convert that into meters, so 8 by 100. So let me find the area. Area will become 100 multiplied to 45000 upon 8. On simplification, we get 56250 meters square. This will be the area which can be irrigated in 30 minutes. Question number 9. This is the last question of the exercise. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter, 2 meter deep. If water flows through the pipe at the speed of 3 km per hour, how much time would it take to fill the tank? This would be the shape of a pipe which is having the diameter equal to 20 centimeter. This 20 centimeter is nothing but 0.2 meters in terms of meter, and water is flowing at the speed of 3 kilometer per hour. 3 kilometer per hour. So this kilometer per hour, I need to convert that in terms of meter per minute, and it is flowing into a cylindrical tank which is having 10 meter as a diameter, so the radius is 5 meter, and the height of the cylinder is meters. What are the given things here? The given things are, we can find the radius of pipe. So radius of pipe, I'll take it as R1. This is 20 centimeter divided by 2. Since it is in terms of centimeter, let me convert in meters. So it becomes 0.1 meter. Alright. I need to find area of the cross section of a pipe. Here, area of cross section of pipe will be equal to pi r1 square. This will be pi times 0.1 square, 0.01 pi meter square. This is the area of the cross section. Now the speed of the water is 3 kilometer per hour. Let me convert that in terms of meter per minute. So it has to be multiplied by 1000 divided by 60. It becomes meter per minute. 3 2 times, so it becomes 50 meter per minute. So we can find out the volume of water flowing in 1 minute will be equal to area of cross section multiplied to speed. Speed is 50. Area of cross section is 0.01 pi. This will become 0.5 pi meter cube. Now they have given the radius of the cylindrical tank and the height of the cylindrical tank. Therefore, I can consider something like this. Let the tank will fill completely in some t minutes. Therefore, volume of water flowing in t minutes will be equal to volume of cylindrical tank. This means that t times of 0.5 pi equal to pi times of r2 square. Here the radius of the cylindrical tank is 5, so 5 times square into the height of the cylindrical tank 2. So we get t value as 5 square. Pi will get cancelled. 5 square into 2 divided by 0.5. So we get this is 25 into 2, which is 50 divided by 0.5. This is nothing but 100. So the tank will completely fill in 100 minutes. So the time taken for the tank by the time taken for the pipe to fill the tank completely is 100 minutes. With this question, I'll end today's session. We shall look into the next exercise in the next session. Thank you.